contains several land features, bodies of water, and a protective layer of atmosphere which all together make life possible. No matter how large they seem, they are just examples of the three phases of matter that naturally exist in the planet, namely solids, liquids, and gases. This fact highlights the importance of chemistry in understanding the world, from the smallest materials in your room to the huge planets and galaxies. They can easily be understood by studying the particles that make each of them. On this video lesson, we will talk about the properties of solids, liquids, and gases based on the particle nature of matter. Matter and energy make up the entire universe. Matter is made up of very small particles. The substance that we eat, drink, breathe, write on, and sit on are all made up of these tiny particles. It is too small, and we need the most powerful microscope to see them. As such, one needs to understand what these small particles are doing so as to understand why substances behave in the way that they do. Matter is anything that occupies space and has mass. Mass is the fundamental property of matter. It is the amount of matter or substance that makes up an object. It remains constant for any proportion of matter that remains the same. It is measured in units called kilograms, which can be abbreviated as kg, while volume is a measure of the amount of space occupied by an object. It is the amount of 3D space a substance or object occupies. The relationship between the amount of mass and the amount of space is an important property of matter. We usually state this property as the ratio of mass and volume called density. Let us try this simple activity. Which is matter, which is not? So we have here smoke, milk, a leaf, light, heat, salt, and air inside a baby pool. Now, can you identify which among the pictures shown on the screen is considered as matter? Alright, we can say that salt, leaf, air inside a baby pool, smoke, and milk is matter because the mass of these samples can be measured. A while ago, we defined matter as anything that occupies space and has mass. Therefore, if a given sample has a measurable mass, we can say that it is a matter. If we collect smoke and air in a container and covered it afterwards, it will be observed that smoke occupies space and it has mass, or its mass can be obtained. Whereas heat and light, they do not occupy space because these are not matter. Heat is energy in transit, and light is a form of energy. One cannot buy a kilogram of light nor an inch of heat, but we can measure the temperature or the degree of hotness of an object. Matter is made up of tiny particles. A tiny particle of a chemical element is called an atom, which may or may not exist independently. Molecules refer to the group of atoms that the bond binds together, representing the smallest unit in a compound. Two or more identical or distinct atoms are chemically bonded. So the smallest particle of matter is an atom, while molecules refer to the group of atoms that the bond binds together, representing the smallest unit in a compound. The way the molecules are arranged in a substance determines the state of matter. Basically, matter exists in three phases: solid, liquid, and gas. The behavior and interactions of atoms and molecules within a substance determine its phase. Molecules, compared to atoms, are larger particles formed by the combination of two or more atoms. Water is a molecule. It is made up of one oxygen atom and two hydrogen atoms. One can distinguish among solids, liquids, and gases using the macroscopic and microscopic level. Macroscopic refers to properties that can be observed by the five human senses, aided or unaided, while microscopic refers to properties that are too small to be seen even with the very best of microscopes. On the macroscopic level, solids, liquids, and gases can be distinguished from each other on the basis of their shape and volume. That is, solids have definite shape and volume. Liquids have definite volume but indefinite shape. It assumes the shape of container. Gases have indefinite volume and shape. They take the size and shape of whatever container they are placed into. Let's take a look at this illustration. As you can see, a solid can hold a shape. It has fixed volume. Liquid takes the shape of a container and it has a fixed volume. Whereas gas takes the shape of container and takes the volume of container. Suppose you are given coin, water, and a balloon. Using a magnifying glass, take a closer look at each material. Macroscopically, we can distinguish the phase of each material, respectively, and can be described using the properties mentioned a while ago. But have you ever wondered how the small particles inside each material look like? So, how the atoms inside each material look like? You might be asking also what the atoms are doing inside these materials or how atoms behave. Probably, you would need a magnifying glass that can be zoomed 1,000 times to see that. At the microscopic level, solid particles are moving very slowly. This is as shown in figure A. Solid particles are packed tightly together in a fixed position. In liquids, just like here in letter B, The particles are close together, but they can slide past with one another. Thus, they move faster than solid particles. In letter A, solid seems like the particles are vibrating, whereas in letter B, in liquid particles, they move faster than in solid particles. Whereas for letter C, the particles of a gas, on the other hand, are moving very rapidly and feel very little attraction for each other. They fly off in every direction. Matter, be it in solid, liquid, or gas, is always in constant random motion and hence possesses energy of motion known as kinetic energy that is dependent on the temperature. This means that as you increase the temperature, the atoms and molecules will gain more and more energy and therefore will make them move even faster. Solids are not compressible and they do not flow easily. Liquid is not easily compressible and it can flow easily, while gas is highly compressible and it flows easily. So here are the other properties of matter in terms of phase of solids, liquids, and gases. The kinetic molecular theory of matter describes the following key points. All matter, solid, liquid, and gas, are made up of tiny particles called atoms, or atoms that are joined to form molecules. These particles are in constant and random motion. Particles in motion possess kinetic energy. Their motion increases as they gain energy. There is a transfer of energy between particles, atoms and molecules, during a collision among them. Particles or molecules in gases do not exert large forces on each other unless they are in collision with each other. Collisions between these particles are perfectly elastic. Molecular motion is greatest in gases, less in liquids, and least in solids. The kinetic molecular theory is very useful in explaining why the phases of matter differ in movements and arrangements. It also describes the forces between molecules and the energy that they possess, as well as the effects of temperature and pressure on matter. Attractive forces exist within and between particles. The attractive forces that hold particles together are called intramolecular forces. The prefix intra means within. There are forces of attraction called intermolecular forces. The prefix inter means between or among. Intermolecular forces can hold together identical particles such as water particles in a drop of water, or two different types of particles such as carbon in graphite and the cellulose particles in paper. The properties of solids and liquids are further described as we relate them to the attractive forces. Here are some of their properties. Properties of solid. Density. It is the ratio of mass per unit volume. Normally, we say that solids will always sink in liquid or water because solids are more closely packed than liquids and gases. Solids have greater density than liquids and gases, but solids have unique properties. Can you explain why ice cubes float on water? It is because water is less dense as a solid than it is as a liquid. The three-dimensional structure of ice keeps water molecules farther apart than when they are in liquid water. The water molecules in ice are less closely packed together than in liquid water. There are more spaces between the molecules of ice. This results to more particles per unit volume in liquid water than in solid water. Next is crystalline solids. The individual pieces of crystalline solids are called crystals. Crystalline solid is a solid whose atoms, ions, or molecules are arranged in an orderly geometric three-dimensional structure. The shape of a crystalline solid is determined by the type of unit cell from which its crisscross framework is built. A unit cell is the smallest arrangement of connected points that can be repeated in three directions to form a lattice. Next, we have metallic solids. We defined metallic solids as consisting of positive metal ions surrounded by a sea of mobile electrons. The mobile electrons make metals malleable or easily hammered into shapes, and ductile, meaning easily drawn into wires. When force is applied into a metallic solid, the electrons shift and keep the metal ions bonded in their new positions. Mobile electrons make metals good conductors of heat and electricity. And we have amorphous solids. Not all solids contain crystals. An amorphous solid is one in which the particles are not arranged in a regular or repeating pattern. The term amorphous is a Greek word that means without shape. An amorphous solid forms when a molten metal cools too quickly to allow enough time for crystals to form. Some examples of amorphous solids are glass, rubber, and plastics. Liquids have densities that are greater than gases or its vapor at 25 degrees Celsius and 1 atmosphere of air pressure. An enormous amount of pressure must be applied to reduce the volume of a liquid by even a few percentage. Here are some of the properties of liquids that are related to the intermolecular forces. One is fluidity. Fluidity is the ability to flow. Gases and liquids are classified as fluids because they can flow. Liquids are less fluid than gases, but liquids can diffuse through other liquids. A liquid food coloring can flow and completely mix with water. Let us compare water and propane gas as to their fluidity. Propane gas is more fluid than water, as propane gas will readily evaporate and fill the spaces in the room, while water will stay in the base of the container. Next is viscosity. Were there times when you got tired of waiting for a ketchup to flow out of the bottle? That can be explained by the concept of viscosity. Viscosity is a measure of the resistance of a liquid to flow. The particles in the liquid are relatively closer due to their attractive forces, causing the movement to slow down. The viscosity of a liquid is determined by the type of intermolecular forces involved, the shape of the molecules, and the temperature. The stronger the intermolecular force, the higher the viscosity. The size and shape of particles affect viscosity. Let us compare two molecules of different sizes, a big one and a small one. If both have similar attractive forces between them, the big molecule will have a greater viscosity than the small molecule due to its size. With this, the big molecule will move slower and the smaller molecule. With this, the big molecule will move slower than the smaller molecule. Molecules with a long chain, such as cooking oils and motor oils, are thick and slow to flow because in long molecules, there is less distance between atoms. The molecules are more compact, so there is greater chance for attractions between atoms. Next is viscosity and temperature. There is a saying that if it is cold, the more one curls and become immovable. Observe that when you put margarine into a hot pandesal, it melts right away and is easy to spread. This is due to the increase in temperature. When there is increase in temperature, there is an increase in the kinetic energy. Applied to the molecules, it is easier for the molecules to overcome the intermolecular forces that keep the molecules from flowing. Next is surface tension. Have you tried letting a thin blade float on water? Or have you seen a spider walking on the surface of a pond? Or why are soap bubbles spherical? How can you explain this? The water's high surface tension allows the water strider to walk on the surface of the water in the pond. It is also the reason why the thin blade floats on water. Surface tension is the energy required to increase the surface area of a liquid by a given amount. It is a measure of the inward pull by particles in the interior. For particles at the surface of the liquid, there is no attraction from above to balance the attraction from below. There is a net attractive force pulling down on particles at the surface. The stronger the attractions are between the particles, the greater the surface tension is. Water has a high surface tension because its molecules can form multiple hydrogen bonds. Soaps and detergents decrease the surface tension of water by disrupting the hydrogen bonds between water molecules. When the bonds are broken, water spreads out. Do not wash your dirty clothes with water only. Water cannot remove the dirt from your clothes because dirt particles cannot penetrate the surface of the water drops. You need surfactants like soaps and detergents. Surfactants are compounds that lower the surface tension of water. Capillary action: when water is placed in a tube like the graduated cylinder, the surface of the water is not straight. The surface forms a concave meniscus. There are two forces at work: cohesion and adhesion. Cohesion is the force of attraction between identical molecules, while adhesion is the force of attraction between different molecules. Because the adhesive forces between the water molecules and the silicon dioxide in the glass are greater than the cohesive forces between the water molecules, the water rises along the inner walls of the cylinder. If narrow tubes, called capillary tubes, are used, then the action is called capillary action or capillarity. Why do paper towels absorb water? It is primarily because water is thrown into the narrow spaces below those cellulose fibers in the paper. These water molecules also form hydrogen bonds with the cellulose molecules. Disposable diapers draw water from the surface of the diaper toward the interior by capillary action. The diaper can absorb about 200 times its mass in fluid. Density. Liquids have density too. Density of the liquids varies and gives various effects. The density of a liquid with a constant volume varies according to its weight. If the liquid has a higher weight, the density will also be higher. And finally, we have the properties of gases. One is volume. Gases do not have definite volume. This means that a gas will fill whatever volume is available. This space is where the molecules move freely. If you have a mixture of gas, such as air, the various gases will coexist within the same volume. The volume of a gas is measured using a calibrated tube called burette. The standard unit for volume is cubic meter, but we often use liter and milliliter or cubic centimeter. Pressure. Gas molecules are in continuous motion and frequently strike the walls of its container. This movement exerts a force over the area known as pressure. Next is temperature. An important property of gas is temperature. It is a measure of the average kinetic energy of the particles in a sample of matter. An increase in temperature causes a gas to expand, thus increasing its volume. A decrease in temperature causes a gas to contract, thus decreasing the volume. Temperature is likewise proportional to pressure. That is, in a fixated volume of gas, increasing the temperature will increase the pressure, and decreasing the temperature will decrease the pressure. The behavior of gases can be further explained by the gas laws. As time goes on and ideas progress, we realize that there are other phases of matter. One of them is plasma. Plasma is considered as the fourth phase of matter. It is a hot ionized gas which allows both positive charge ion and negative charge electron to coexist. Being an electrically charged particle, plasma is strongly influenced by electric and magnetic fields. This makes it different from neutral gases. About 98% of the matter in the universe is in plasma phase. It is the most common and yet the least familiar phase. It fills the interplanetary space. The Sun, stars, planets, and certain planetary moons are all consist of plasma. Though abundant in the universe, plasma only occurs on Earth like in lightning bolts, auroras, and fluorescent light. Gases can become plasma in several ways, but all include pumping the gas with energy. A spark in a gas will create plasma, like the torches that are used in industry to cut metals. Next is the Bose-Einstein condensate or BEC. BEC represents the fifth state of matter beyond solid. BEC was predicted by Albert Einstein and Satyendra Nath Bose, and the concept of BEC in gas was realized by Eric Cornell and Carl Wyman in 1995. It appears when scientists refrigerated particles, called bosons, in a very low temperature. Cold bosons merge to form a single superparticle that is more like wave than an ordinary speck of matter. BECs are fragile and light. They travel very slowly through them. BECs are more ordered than solid. Atoms in solids are locked into roughly the same location as the other atoms. When BEC is visible, each part that one can see is the sum of portion of each atom, all behaving in the same way, rather than being the sum of atom as in the other phases of matter. A new form of matter, called fermionic condensate, was discovered by NASA-supported researchers, physicist Deborah Jean led scientists who produced the first fermionic condensate in December of 2003. Jean created the substance by cooling a cloud of 500,000 potassium-40 atoms to less than millionth of a degree above absolute zero. Fermionic condensate is so new that most of the basic properties are unknown. Certainly, they are cold. Fermionic condensate and BECs are related. Both are made of atoms that coalesce at low temperature to form a single object. In a BEC, the atoms are bosons, whereas in a fermionic condensate, the atoms are fermions. So let's check your understanding. Number 1, which of the following has mass? A. Heat, B. Sound, C. Stone, D. Light. Number 2, Which of the following properties of matter is demonstrated if you measured 20 ml of water? A. Color, B. Volume, C. Density, D. Viscosity. If placed inside a syringe, which of the following is not compressible? A. Oxygen, B. Air, C. Milk, D. Nitrogen. If poured, which of the following will not take the shape of a bowl? A. Scotch tape, B. Cooking oil, C. Soy sauce, D. Ketchup. Number 5. Which of the following will retain its shape and volume if transferred in a container? A. Air, B. Corn soup, C. Soft drinks, D. Block of wood. Okay, let us answer for number 1, letter C, stone. Number 2, B. Volume. Number 3, C. Milk. 4, Scotch tape. And 5, block of wood. So, thank you for watching this video lesson.